Hello everyone, welcome to the solution of LeetCode problem 1591 named a strange printer 2. In this problem, there is a strange printer with the following two special requirements. On each turn, the printer will print a solid rectangular pattern of a single color on the grid, and this will cover up the existing colors in the rectangle. Once the printer has used a color for the above operation, the same color cannot be used again. Now, we are given a two-dimensional matrix named target grid, where each of the element is the color in the position of row and column in the grid. Now, we have to return true if it is possible to print the matrix, otherwise we have to return false. Now, let's consider the first example. Here, we are given a two-dimensional grid of size 4 by 4. Initially, all of them are 0. Now, in one operation, we can print the color 1 on the entire grid. So, all of the 16 cells will become 1. And in the second operation, for this inner blue rectangle, we can print the color 2. So, we can see that it is possible after two operations, we can get the pattern in this last grid. So we have to return true. Now if after some iterations we did not find the respective grid, we have to return false. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken the same example. Now the question is, how can we solve this problem? Basically, let's think in a reverse way. Suppose this is our given matrix and we have this inner 2 by 2 grid where each of the element is 2. Now, this is our one color. Now, if we remove this color 2, the grid will become this and all of the element is 1. So, the color is 1. Now here, the question is, do you find any dependencies? The dependency is, at first, the grid should be colored 1. After that, some rectangle will be colored 2. So, 2 is dependent on 1. And if any kind of problem, we have to deal with the dependencies, we will use the topological sort to solve this problem. And to implement the topological sort, we will use the Kahn's algorithm. Now here, the algorithm is pretty simple. Suppose, according to the problem statement, the maximum dimension can become 60 by 60. So here, that means the grid can have 60 rows or 60 columns. So at most there are 60 color can we have. Now we have to first find the dependency graph. So how will we find the dependency graph? Now for each of the color, we will store its starting point and ending point into a separate container. Suppose for the color 1, its starting point is this and its ending point is this for the rectangle. That means it is the top left corner, it is the bottom right corner. Now for the color 2, its top left corner is this, its bottom right corner is this. Now here, it is our given matrix. So for the color 1, its range are this position to this position. Now here we have seen that in this rectangle, except for the color 1, we have found the color 2 again. So here we can see that, or we can tell that color 2 is dependent on the color 1. This is the basic intuition. That means if any kinds of colors rectangle, we find another color, so we can say that those second color is dependent on the first color. That means this grid should be initially printed by the color 1. After that, we should print it by color 2. So we can say that color 2 is dependent on the color 1. Similarly, we will do it for each of the colors and we will build the dependency graph. After that, we will run the topological sort algorithm. And in the topological sort, we know that we have to initialize the BFS on the node which has the in degree of 0. So here our node has in degree of 0. That means it is not dependent on each other or any other. That means no other connections or no other edges is coming towards it. So here in this problem, we have seen that the node 1 has in degree of 0. That means initially we can fill the entire rectangle by the color 1. So here, similarly, as we are doing this algorithm for all of the 60 color, so we have to mark it as well. Now, suppose initially our node 1 has in degree 0. So according to the Kahn's algorithm, we will visit it and we will remove these outgoing edges from node 1. So now node 2 has in degree of 0 because the edge coming towards it is null and void right now. So we will visit the node 2. So far, we have seen that by using the Kahn's algorithm and running the BFS in the level by level manner, we have visited all of the node. So we have to return true because after building this dependency graph, which is the exact representation of this grid, if we can able to visit all of the node, that means we can able to print the color into the grid. And this is how basically we're gonna solve this problem. I hope you understood the algorithm. Now let's move on to the code. In this problem, to understand the code, we are given this function is printable, which has a two-dimensional grid as a parameter. Now we are calculating the dimension n and m, and to store the top left and bottom right for each of the color, we are taking these vectors x max, x min, y max, y min. And to store the in degree, we are taking this vector name in. Now we are taking also a adjacency list. Now for each of the cell, we have to calculate the maximum row, the minimum row, and the maximum column and the minimum column. So here, for each of the cell, we store the current color into a variable name color. Now, the maximum row will be the maximum of I and the maximum color presented. The minimum row will be the minimum of I and the minimum color presented. Similarly, for the maximum column and the minimum column as well. So here we have found the top left and bottom right corner for each of the colors. Now, in this loop, we are building the dependency graph. So here, for each of the color from 1 to 60, we have to iterate each of the cell into its between its top left and bottom right corner. Now, if there we find any of the cell which is not equal to the color, that means this cell basically dependent on this color. So here we have to insert the cell into the adjacency list of color and increment the in degree of the respective cell. Finally, for each of the color which has the in degree 0, we have to insert it into the queue, and we are taking a variable name visited to store the or to visit how many nodes we have processed so far. So currently our queue having all of the node which has the in degree of 0. So here we are using the Kahn's algorithm. While the queue is not empty, we are storing the front element of the queue into a variable current and we are removing it. Now we are increment the visited counter because we have processed a node. Now for each of the children into the adjacency list of current, we are decrementing the child or the in degree of the child. And if the in degree of child is equal to 0, we have to insert it into the queue for the next iteration. Now we have to return if the number of node is visited is equal to 60. Because if the number of node visited is 60, that means we have processed all of the 60 different colors. So in this case, we have to return true. Otherwise, we have to simply return false. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.